Right. So thanks again for the invitation to join. I'm more than happy to take questions in the chat. The plan that I had was to try and go through these slides in around about half an hour thereabouts, and then capture any questions and discussions later. So hopefully I can keep to time. So I'll shoot through. So again, thanks for the invitation to talk to everyone, and almost happy holidays. So there's going to be a number of acronyms that are thrown at people, and hopefully people can calibrate as I go with the acronyms that I'll hopefully be describing. You may have also noticed my accent is Australian, so hopefully it's not too much of a challenge to try and understand me. But where I'll start here is just the overview of what the talk is going to target here. So talking about model intercomparison projects, or MIPs. So a new indicated CMIP, which is the Coupled Model Intercomparison Project, and that evolved from the atmosphere only, so the AMIP, Atmosphere Model Intercomparison Project, that started off the MIPs back in 1989. Then I'll look through to CMIP6, which is the current phase, which is currently wrapping up, of the CMIP6 project. I'll try and point out a number of Arctic and Antarctic of interest experiments and activities that resided within the CMIP6 project, and then start focusing on ongoing planning that we have for CMIP Next, beyond CMIP6, and then the CMIP7 planning, which is something that we're anticipating will be starting on a timescale of 2 to 3 years' time. So the MIPS overview to start off with. So first up, CMIP is very much a team sport. There are many institutions, countries, agencies, modelling groups, infrastructure providers, and just a huge array of people that have, communities that have come together to make CMIP a reality. So the US Department of Energy has provided 35 years of support for the PCMDI project, which is based at Lawrence Livermore Laboratory over in California, which is where I'm based. And the ESGF acronym it stands for the Earth System Grid Federation, which is a federated software stack that houses all of the data that has been collected across the phases of CMIP. So with CMIP6, it's around about 25 or 26 petabytes of data. So it's pretty big infrastructure. And primarily, they are distributed on 3 countries. So the UK, Germany, and in the US, where we've got a consortium that contribute to the US contribution to ESGF. So the ESGF project was initiated in around about 2007. There was a recognition that it wasn't possible for any one institution to house the data that was being generated by the CMIP project, so it needed to be distributed, a consortium approach. And there's been many recent contributions from numerous other contributors, not just DOE. So the EasyNES and the ENES RI follow-on are activities that are funded as a consortium over in Europe, and they've been heavy contributors to the ESGF project, in addition to the CMIP infrastructure that supports the ESGF as well. So there's numerous other regional projects from other institutions, including DKZ and IPSL, Germany and Italy, INCEDA in the UK, the ESDOC consortium, and then here in the US, NASA, NOAA, and other agencies as well. So where we stand at the moment with the CMIP6 project is we have around about 30 or so ESGF nodes represented by 17 countries. And we've got quite a large array of models, 131 models, 49 institutions representing 26 countries that are contributing to the project, in which 17 countries are contributing to the infrastructure. So you can see a number of logos on the right-hand side there, but there's many, many more involved. Okay, so what are MIPs? So again, this is model intercomparison projects. So it started out with the atmospheric only MIP, the AMIP project back in 1989, which initiated the PCMDI project that I work for. CMIP stands for the Coupled Atmosphere and Ocean MIP, and that was initiated around about 1995, which evolved beyond just atmosphere ocean to include Earth system models in the prior phase, CMIP5. So you can see a schematic on the right-hand side there, which indicates that there's been this evolution of the CMIP project through phases. 1995 was CMIP1, CMIP2 was around about 97, and then CMIP3 was when things really became very organised, with standardized protocols, experimental protocols, so simulation lengths, model components that were included, for example, and also some coordination of the forcing data sets being used, in particular for the historical experiment. And then also a standardization of the data formats, the identities of the quantities that were being captured from the model output, the quantities themselves and how they were defined. And the use of MIPS now has expanded broadly. It's now used well beyond just modelling activities. So there are a number of other activities that are MIPS. The Input for MIPS project is another project that is led at PCMDI by myself, actually, and that's coordinating the forcing data sets for use in CMIP. And then OBS for MIPS, which is another project which PCMDI is leading, which is trying to coordinate many of the observational data products that are used in model evaluation. So a timeline of the MIPS, there's a lot of information here, but the take home is that this has been happening for quite some time, and it's very much been an evolution, not only from the science, but also for the computer science that's been serving the project. So at the top there, we've got when the planning begins and when the operations or the delivery of data sets begin. When AMIP1 on the left-hand side started, things were pretty simple. They had one experiment. It was pretty idealized. And so things began and data was available pretty quickly. As we moved across through AMIP2, CMIP1, and across to the right-hand side, the complexity has considerably increased. The number of models that are contributed, the different components from the models, etc. So you can see that the data volumes have been increasing exponentially over time, actually. The infrastructure itself is something that in the early phases of AMIP and CMIP, the DOE-supported Livermore infrastructure served the international community. But in CMIP5, there was a recognition that it wasn't possible for one institution to host all of this data in a resilient way. So that's where the federation part of ESGF comes in. And that's where quite a number of international collaborators started working with DOE and some of the other US agencies to build this federated system where the data can be published by modelling groups close to where they run and generate the data sets. And then the data can be federated and shared, replicated around these different locations, including quite a big installation we have across DOE here in the US. So we've moved from AMIP1 in '89 to the very latest phase now, CMIP6+, which is capturing information from model simulations that have occurred or are beginning now after the CMIP6 phases has concluded. So down the bottom there, there was also an evolution of data formats. We've become much more standardized now, which means that using these data sets is far easier than it used to be back in the AMIP1 days. So we've standardized around the CF climate and forecast conventions around the NetCDF4 data model, which really makes it pretty easy for people to undertake analyses across the different phases of CMIP. So this is the graphic that tries to quantify some way what we saw on the previous slide, and you can see that there's been this evolution over time with a huge increase over the last phase, CMIP6, where there was an order of magnitude more experiments that comprised the project, and the model diversity actually increased quite markedly as well, including the number of countries that are contributing, institutions, etc. So there's been quite a significant growth, and we're expecting that growth to continue into the future. So this is an attempt to try and quantify the impact of these MIP activities through time. So down the bottom there in the star was the Charney report that was published in 1979. Quite a number of, some of the major modelling centres that were doing climate change research back in the 1970s had undertaken independent experiments that tried to quantify what the impact of CO2 could be. And that was a US Academy's report. But then we had these more organised activities. Fangio was a very focused project on cloud feedbacks that initiated some of the MIP coordination. But then the MIP acronym actually became quite dominant through the AMIP phases. So Gates et al., for example, Larry Gates actually founded the PCMDI project at Livermore, and that's where the project kind of kicked off. And so you can see what's happened over time. These are citation counts for these papers that you can see in the different colours. And with CMIP3, we had this really big uptick in people paying attention to the CMIP output and using that for numerous reasons, including impacts and mitigation adaptation research as well. And then with CMIP5, the the number of folks that were paying attention to these data sets grew exponentially. And that has continued now with CMIP6 as well, which has broadened considerably the science focus. So where we are with CMIP6, so CMIP is very much driving the science and informing policy, and it was the largest phase. You can see some numbers on the right-hand side there that were captured in the previous slide. There's been a consistent improvement in model complexity and also model performance as well, which is captured in that graphic at the top there. And then some of these plots that we've all become pretty familiar with, which are simulated future projections of where we could be, depending on what path we choose with CO2 emissions as well. So if we don't start reducing CO2 emissions, then we're going to have quite a warm world by the end of this century. So the current phase is schematically outlined here. So the core, the DEC in the center there, stands for the Diagnostic, Evaluation and Characterization of CLIMA. And there's 4 core experiments, which all contributing models are requested to do, which tries to capture the response of the models to idealized forcing and also the historical record of forcing as well. In addition to that, we also have a number of community MIPs, which are focused on different science questions. So focused on biases, for example, forcing and feedback responses, variability, predictability, and future projections. And then also more recently, negative emissions pathways, which is something that's trying to figure out how we mitigate the impacts of climate change and get on with the job of dealing with the challenge that we've got. So this schematic kind of outlines a number of different activities. And as I said before, the DEC is the core component, and then the community MIPs are very science focused as well. So these things are built around common standards and open access. So the infrastructure facilitates access to these data sets that the modelling groups choose to contribute to by organised by the MIP, the activities and the science of the communities that are building the protocols of the experiments, for example. So when we look at the published data from CMIP6, there is a lot of it. So this plot on the right-hand side indicates the different activities, these MIPs, focused on different science questions. So AirChem MIP is very much on different short-lived climate force responses of the atmosphere. C4 MIP is a carbon focus, et cetera. You can see that some of the largest contributions are to the CMIP project itself, which is this DEC core, the idealized and historical simulations. And then the other large component is scenario MIP, which is the future projections. So there's over 7 million distinct data sets. There's more than 20 million independent files. There's a lot of information, and this archive is going to be serving us for a very long time into the future. There was seamless delivery thanks to the ESGF consortium. They did a lot of work to try and prepare the network for delivery of CMIP6 through data challenges and stability testing. It's worked really well, so we're really grateful for their efforts. And the data sets, as I noted, are just in a consortium of a huge amount of information, more detail than I have time to go into right now. But the footprint is petabytes. So we're talking about, big science, big data. So the CMIP6 project really anchored a number of components of the AR6 IPCC report. There was an identification that in CMIP6 we had what were identified as hot models, models that had climate sensitivity far larger than the assessed range of the more recent IPCC, the WCRP report that Steve Sherwood led in 2020. The AR6 included the first constrained projections where we were using some of the DEC simulations to try and evaluate how the models were performing over the historical period, and then weight models based on their historical performance, which then led to a downward correction, which is those 2 panels at the top there. The unconstrained CMIP then constrained downwards towards the WCRP ECS range. So what we've learned through this process is getting forcing and model responses to the forcing right underpins the observed climate change attribution and the utility of the future projections. And people using particularly the scenario MIP projections into the future data is growing at a huge step. So it really raises the importance of model evaluation, making sure that these models are fit for purpose, which really requires a pretty tight feedback loop between folks that are generating these simulations, assessing the simulations, and then the downstream users. So there's really a move now towards operational climate services, and I think that may dovetail a number of folks that are on the call actually. So accessing information about CMIP6, which I thought was probably the most relevant for the community connected today. So we have a lot of information that is available. Because there is so much information, you need to figure out ways of being able to access the information that you want. So what I've undertaken here is a screen grab. The QR code should get you to this page if you were interested. A number of experiments within CMIP6 that included the keyword Arctic. So I've got a couple of slides following on here, but basically there are a number of experiments here that are focused on ocean simulations. And then also the PA-MIP, the pattern amplification MIP, is very much focused on the Arctic and Antarctic responses to ongoing climate change. So there's the logo here, the QR code on the page there, and these slides will be available at a later stage if you're interested in them. We also have additional information to guide people that want to use the data sets, to guide people that want to contribute data sets to the CMIP phase. This is all CMIP6, and that project now is spinning down. But the information that is available from these is very useful, I think, for people that want to start thinking about contributing to the CMIP project. And again, QR code and the link there, and I'll provide this information if people are interested. We also have organised a lot of the information that people need in order to try and derive information from these petabyte data store. And so we've got what is termed the CMIP6 control vocabulary, which captures a lot of information about different models contributing to CMIP, the different experiments, and a lot of information that you can slice and dice to try and get at the information that you want, and then how you'd want to guide interrogating, this multi-petabyte data set that sits on the federated ESGF system. So just trying to pull out a number of things that are relevant to the community, I think. So FAF-MIP, you may have identified that on a previous slide. That was the flux anomaly forced MIP, and very much focused on ideal as surface force simulations targeting ocean responses to momentum, heat and freshwater fluxes. One of the experiments in there was an ant water stress. So it was basically looking at the cryospheric freshwater components into the Southern Ocean, and trying to gauge how the model responses to that forcing. There's also the polar amplification MIP. I might have mentioned this one before, which was Arctic and Antarctic idealized pre-industrial and future sea ice patterns, time slice and transient experiments. So time slice being a snapshot versus transient that may extend, say, from the 1850 period through to the present day, so the time evolution. There was also the ice sheet MIP, which was very focused on the ice sheet responses. So the timescales are far longer, obviously, than some of the atmospheric responses, for example. And there was another MIP called the sea ice MIP, which was created to make sure that when simulations were run, valid sea ice data sets were actually requested as part of the output from a historical experiment or a pre-industrial control experiment, or the scenario experiments as well. So just making sure that the information that the models were providing was usable and useful to folks interested in sea ice. So there's been a number of parallel activities outside of the CMIP formal scope. Many of these are focused on ice sheets. So IS MIP stands for the ice sheet MIP, and quite a number of different variations of those. All of these acronyms are something that is pretty easy to Google. MISA MIP, Sophia MIP, and Glacier MIP all have web pages, which are linked through these slides, but more than happy to provide the slides at a later stage, which means you can find these things. If you do a Google search, you should be able to find them. So these are ongoing projects at the moment that are happening in parallel to the CMIP6 phase, and there's quite a number that are expecting to continue into the CMIP6 plus phase and CMIP7 phase going forward. So there's a lot of stuff that is very relevant to the Arctic and Antarctic science. So talking about CMIP next planning, so there was a recognition towards the end of the CMIP6 cycle that the CMIP project had gotten so big that we need better communication and administrative support. And so the CMIP International Project Office was established in 2022. So the IPO, International Project Office team, consists of the director, Eleanor, a program manager, Bryony, science communications officer, Beth, a technical officer, Dan, and then Alice, who's helping out with some administrative as well. They're based in Harwell in the UK. And what they've done is really turbocharged their ability to consult and engage with this broader community that continues to expand, not only contributors to the CMIP6 project, but many folks that are very interested in getting their hands on the CMIP output to try and do the science that they want to do, be it impacts or adaptation planning, mitigation, etc. So through the IPO's assistance, we managed to expand our community consultation. So there's a number of things I identified here. We had a CMIP6 community survey, which hopefully a number of folks on the call actually provided feedback to. That concluded in March 22. We've had some discussion about the priority variables consultation, so making sure that the information that we're capturing as the models are running the simulations and made available to folks at the end of the simulations is right. We've had a number of drop-in sessions that are focused around, planning and discussion of the CMIP7 experimental design. We've had one focused on the forcing data sets being generated next generation for CMIP7 use and variables as well. And we've also had a number of other activities. We've had a CMIP forcing survey, which was focused at many of the modelling groups to try and gauge what worked well, what didn't work as well, and how we can do things better. And there's also been ongoing other workshops, including Scenario MIP, which is very much focused on these future projections as well. So that's just the beginning of where we've been with certain things. We've had quite a number of town halls, both at the EGU and the most recent AGU meeting, and a lot of opportunities for folks to engage, spin up on what is happening in the CMIP project and how they can engage and provide feedback and help us out in speccing out the next phase. So there's a link down the bottom there, the WCRP CMIP website. That's a news page, and that's where a lot of this information is collated. So definitely a place to look at if you're interested. So from the CMIP6 survey, we had suggestions that were guiding the planning for the CMIP7 phase, and that was suggesting that we had pretty right with CMIP6, so no big structural changes, but an evolution beyond CMIP6. There was a keen interest to retain the IPCC alignment, which is something that's happened more regularly in the last number of phases of the CMIP process. So definitely CMIP3, CMIP5 and CMIP6 have aligned quite tightly with the IPCC assessment reports, the AR4, the AR5 and now the AR6 that was published a couple of years ago. So there was a recognition that there's a need for a greater focus on climate impacts and adaptation relevant experiments, including updated scenarios. There was a need to operationalise a number of the critical elements, which we haven't done before, including the forcing in particular. So delays in forcing had some pretty major issues on delaying delivery of CMIP6. And then build on the substantial internationally collaborative infrastructure progress, to really facilitate the science communities and enable even more uptake and usage of these data sets and data access. So there was a real call for continuing engagement and enhancing community input into the experimental design process, which is one of the reasons we've had all these surveys and interaction opportunities. And there'll be a number of those that I identified towards the end of this slide deck. And then really nurture the early career folks as well to try and get engaged in CMIP as an ongoing capability, and engage in the Global South too, to make sure that the whole globe is represented and involved in developing the next phase of CMIP. So a number of community concerns were raised, and we've got, what the concern was on the left with the responses on the right. And so there's been a lot of information fed through to us, and we're responding to this in the experimental design and in the way that the infrastructure, et cetera, is responding. So very much trying to alleviate pressures and make sure that we're really prioritising the simulations and the science that people really need. Trying to better connect, for example, across the different IPCC working groups, and do a better job of trying to entrain a lot of early career folks so we can really try and help ourselves out with a broadened contributor base. So one of the things that was identified was the need to have focused task teams that focus on an issue or an opportunity moving forward from CMIP6 moving forward. And that's where these CMIP task teams came about. So there's a number of task teams that have been established, focused on CMIP data access, the citation of the data sets, the data request, which is the variables that we're requesting from the different configurations of the models and different experiments. The forcing data sets being used across different experiments, particularly the historical. Model benchmarking to try and evaluate how the models are going. Are they improving? Do we have, the balance right in how the model development pathline is happening? Documenting the models to make them even more usable, because we know the configurations of the models and how they've been, responding to forcings, for example. And then the strategic ensemble design, which was trying to really understand, what we had in CMIP6 and how we could try and optimize the experimental design to make the most of contributions. And then the Fresh Eyes group, which is very much this early career folks that are helping across all these different task teams. So CMIP is one project in a very, very large and diverse multiverse of climate modelling. And obviously this community is one of those broad components of this modelling multiverse. So CMIP really kind of sits within. It covers quite a large swath in providing input, for example, to Cortex, which is focused on regional simulations, not global simulations. Providing some basis for high resolution simulation evaluation. Importantly, in the IPCC AR6 assessment, there was a real focus on training emulators on these CMIP6 output. And so that's something else that's being done, which is also then leading to AI and ML uses of the CMIP6 data, which is really excellent. So there is a need for the multi-model CMIP ensemble beyond CMIP6. It's something that has been proven as a testing and validation pathway to try and figure out, whether models are fit for purpose. It's enabled enhanced process understanding and pushing models to continue to try and improve while we have observations as well that are also improving our observed view of the world. It's very useful in hypothesis testing. It's also proven very useful in evaluating new observational campaigns. BGC Argo, for example, is providing great new information on the biogeochemistry of the ocean that we can now start evaluating models on, etc. So there's a lot of opportunities there, and CMIP really does fill a need, I think. So CMIP infrastructure, there's a real appetite to leverage the investments that we've made over a number of decades to benefit the wider WCRP activities, which is where the CMIP6 Plus activity aims to try and aid. So new and ongoing MIP activities can request guidance and limited support across the infrastructure that we have in place. And the infrastructure has enabled very responsive activities. So through the IPCC AR6 phase, there was a response to COVID. COVID MIP was established, in addition to a number of other activities that you can see identified in that third bullet point there. So there's a real opportunity here to try and leverage, the work that's been done and try and move towards a more operational structure, which enables much more regular updating of simulations, historical simulation extension, etc. And what we've got to do to realise an operational infrastructure is try and figure out how we can sustainably fund this when many of the contributors to CMIP are actually funded by science activities. And much of things like, for example, forcing science is very much a science research activity with an output being, forcing data sets that are the bleeding edge research output that can then feed into the model simulations, which themselves feed on that too. So the CMIP6 Plus phase is something that we're spinning up at this very moment. At the moment, we're very much trying to learn by doing when it comes to new forcing data sets, for example. So just as a case study, the forcing data sets for CMIP6 historical ended in 2014. And so up until now, we haven't had any updated data sets to extend from 2014 to near present. That's 10 years ago. So it's a long time ago. And we really need to try and figure out ways of bridging that gap. And as these forcing data sets evolve, we need to make sure that the model responses are something that we're keeping track of too, so that we can evaluate to make sure that there's nothing of a surprise with these new forcing data sets, because the models are actually behaving, closer to observations, hopefully, than diverging from them. And then really facilitate and respond to science opportunities. So the intention here is to try and evolve the CMIP infrastructure to really serve the science needs, incremental evolution, really try and feed things like forcing, next generation forcings, enabling modelling groups to pick these things up, provide extended historical simulations, which brings us more up to date than what we've had in CMIP6, for example. And then really try and leverage this to try and enable ready access to these data sets, which are really quite useful in machine learning and AI applications as well. So the intention with the CMIP6+ project is to try and leverage, with few changes, from CMIP6 towards a CMIP7 structure. We really want to try and reuse what we've got, clean things up, make things more logically organised, and make it easier for modelling groups to undertake simulations, get access to forcing data sets, for example, and then publish their output for consumption by the broader community. And we really need to make sure that everyone that's contributing to this pipeline is recognised. So how can we support the infrastructure providers, the forcing data set providers, and ensure that the modelling groups get their recognition for the modelling simulations that they're providing as well. So focus now on CMIP7. So this is now looking kind of, from now into 2 years in the future. So the CMIP design is evolving. We now have this structure that you can see down the bottom there, which has the DEC, which is a familiar acronym, hopefully now to everyone, from prior phases. You've got what is now identified as the CMIP fast track, which is going to be a suite of experiments I'll speak to on the next slide. And then these community MIPs. And the community MIPs were what actually comprised the most of CMIP6. So there was about 20 or thereabouts community MIPs, PA MIP, FAF MIP. A number of the other MIPs that I've identified previously were the community MIPs, focused on specific science questions. And we've got the forcings on the side there. So basically these things all are evolving in their own pace. The CMIP fast track is going to be targeted to the IPCC AR7 report, but the other activities can happen at a timescale that makes sense to the science rather than the IPCC timescale. So we're really focused on a more continuous approach. So the fast track, as I noted, addresses the AR7 needs, whereas the infrastructure standards and tools enable not only that, but the community MIPs, the other activities as well. So this is very much in a response to extensive feedback from the modelling and broader community indeed. So what is the CMIP7 fast track? At the moment, we're going through community consultation. First up, we're consulting modelling groups on version 1. Once we get feedback from modelling groups to gauge their interest in a number of experiments that have been identified, that will be more broadly advertised for community feedback. So I've got some slides towards the end that will indicate timelines for that. So it's the intention of fast track is a compact experiment set, including the DEC. So these evaluation simulations and selected community MIP experiments that focus on the needs of AR7, which itself at the moment is being defined. So it's very much chosen to support these constrained needs rather than, the broader needs of the far larger community. It doesn't reflect any experiment prioritization, but more trying to prioritize in time data simulations that are going to serve the needs of AR7 when there may be some other things that are really scientifically interesting, but may be able to be done in a second tier rather than a priority. So it's very much about temporally aligning, resources to get those things done and delivered on a priority for AR7. So this was done through the Strategic Ensemble Design Task Team, which came up with a straw man proposal, engaged with many of the MIP chairs and the modelling groups as well, and some stakeholders as well to try and come up with this fast track version 1. So this will definitely be something we're looking for community feedback on. So importantly, the fast track or community MIP participation is optional. If modelling groups are not interested by the science that these activities, the experiments are defined by, then it's optional. It's not something they have to do. And that's a key point, I think, that needs to be noted. So just some timelines. You can see where we've come from in October, November, and then through to this month. We've had engagement across the fast track, for example, up the top there. The modelling groups are now reviewing this version 1 prototype fast track, and we're looking forward to capturing all that feedback, wrapping it all up, addressing the feedback, and then making this fast track specification open for community consultation. We've had a number of data requests, the variables being requested from different simulations, consultations, and we've had a number of drop-in sessions, which I'll talk about a bit further along again. So there's been this constant IPCC engagement. The IPCC Bureau was switched out in July, so they've now got new leadership, and they're actually trying to define what the AR7 timelines will be. That'll be decided early next year. So you can see this ongoing plan. In January 24, we'll have this version 2 fast track proposal, which we'll have an open community review for. Please do engage in that when that becomes available. And that will be finalised towards the latter part of, or the mid 2024. So we'll then be continuing to work on all these components, and there'll be the IPCC engagement that continues to happen. In January, they should have a timeline that they're trying to, aspire AR7 towards, and that will then feed into the planning that we have around the fast track and CMIP7. So the community MIPs, I kind of noted this before, but they run on a timeline determined by the MIP needs. You can choose to align with the IPCC timeline, and you can benefit from the infrastructure and tools, etc., and many of the things that we've come to, depend upon within the CMIP community. So just a preliminary timeline. You had this visually before, but we're expecting new forcings, for example, in April 24, and further extensions in early to late 2025 in preparation for CMIP7 prime time. There's going to be a CMIP7 descriptive paper that's published, it's submitted sometime next year. The data request, which are the variables being requested across the different experiment suite of CMIP7, is expected in early to mid 2025. There's some engagement opportunities on that too. And then the scenarios themselves will be landing towards the end of, mid to late 2026. Again, there's a lot of community consultation happening there too. So the modelling centres have been consulted here, and most are planning to start the deck simulations when the new forcings land in late 24 through early 2026. They're also working on model development for the next generation of their models to contribute to CMIP7. And the SGF is also going to be there to make sure that we can continue to serve these data sets and make them available. So I said engagement opportunities. So the data request task team is focusing on a number of thematic papers to make sure the communities that these themes represent are actually getting access. Well, they're requesting the data sets that they need. So I know that there's a number of folks, for example, that have been looking at Arctic outputs, and there may not be the variable that they were chasing. This is an opportunity to engage to make sure that you can place that request and get it in. So the ocean and sea ice calls should be opening fairly soon. The impacts and adaptation call for contributors to this closed on the 30th of November. And there's also land and land ice that will be happening in the early new year. So there's a link there, and more than happy to provide this information to people if they're interested. And as I said before, this fast track consultation on the version 2 early in 2024, that's something that will also be available, and please do feedback, because we're really looking for feedback on this. One of the best ways of knowing about when this information is available would be join the CMIP mailing lists, and you've got the link down the bottom of the page there, but there should be quite a number of opportunities for engagement. We'll have some drop-ins, etc., that are happening focused on different components of how CMIP planning is going on at the moment. So I'm now done. So that's just over 30 minutes. Hopefully we've got 20 or so minutes to interact and answer questions if people have them.
Thank you very much, Paul. This was an exciting talk. I mean, it was nice to see the history of CMIP and how people could engage. So I'd like to open it up to the community for questions. Feel free to unmute and ask your question, or raise your hand, whatever you're comfortable with, or type your questions in the chat too.
I think Richard's got his hand up.
Yeah.
Hi, Paul. That was a great overview talk. I was just really struck by, I didn't realize how much bigger CMIP 6 was than CMIP 5. How well do you know the users of the data? Do you think that that increase is due to more stakeholders, more climate scientists? What do you think is going on?
So we went from 39 to 322 experiments, which is the jump that you're talking about. That was very much driven by communities getting organised and realising that CMIP can help them in trying to answer some of their science questions. And so I think from CMIP5 to CMIP6, it was a much more engaged and active community that wanted to contribute and wanted to use CMIP as a tool to try and, collaboratively answer science questions. And one of the things that I really think CMIP is useful for is the multi-model, because that's a challenge. I think Stephen, yeah, okay, sorry. So if you don't have a multi-model response, how do you know that your model is not an anomaly? I mean, when it comes to the forcing data sets, for example, one of the things that I'm really hoping that we can do is learn by doing. So we know some deficiencies, for example, in some of the forcing data sets that were identified in CMIP6. Hopefully they're going to be rectified in the next generation of forcings, but then we need to make sure that the models are actually giving us a more faithful observed reality than the inverse. And so I think this whole process can be very much a learning by doing, and making sure also that we're paying a lot of attention to the uncertainty around model responses, let alone the forcing responses, etc. So I don't know if I answered your question specifically, but I think it's just been a huge uptick in interest and figuring out that CMIP can actually help in trying to tackle science questions.
Okay, thanks. And just a quick follow-up, I guess. So with the number, it just seems, I guess I'm kind of torn on this point that it seems like you do need to decide which ones are more important, or which ones should be fast-tracked, and or you need to have some type of division of the overall labor, I guess.
Yeah.
But on the other side, it does seem like, inevitably there are going to be, MIPS. The MIPS then don't have the same prioritization as the fast track. Do you have a direct interaction then with IPCC about what they want to have in their next report? Is that how that works? Could you just say a little bit about how CMIP interacts with IPCC?
Yeah, so there's so we have these two panels that Renew identified. So there's the CMIP panel, which is the science focused panel, and the WIP, which I co-chair. I'm a member of the CMIP panel, but I'm co-chairing the WIP. So that the WIP is very much about implementation, really. So there's a lot of, both of the CMIP panel chairs and a number of the panel members are actually IPCC lead authors from AR6. I'm one too, actually. And so there's a pretty good understanding of what was needed back in AR6 and how things worked when it came to CMIP6 data being made available, etc. That pain point is one of the primary motivations for a fast track, because what happened was there were delays in the system, which meant that we didn't get to, we got all the way through to like the final government draft, and we were still pulling, data down from ESGF, which hadn't really been looked at yet. And so trying to circumvent that issue this time around is very much what the planning is trying to focus on. So I'm leading the forcings task team. We had problems with forcing delivery. We had problems with the forcings themselves that then led to delays as these data sets became available, and it pushed the timelines out, which made it really difficult for modelling groups to try and meet the AR6 deadlines. Very much we're trying to build, prioritise things in a way that, if you have a tier 0 experiment, that sends a message to a modelling group that, at least in AR7 timelines, we would prefer to have this tier 0 before we have a tier 1, tier 2, tier 3, and just trying to make it very clear as to how we've organised these things. So, I mean, scenarios are going to be a core component of AR7, I would be presuming. I would be hoping that AR7 is going to pay a lot of attention to the deck to evaluate the models, which means that then that fitness for purpose question can be answered before you go and blindly use, 200 model simulations without any guidance as to how useful they are in reproducing planet Earth. So I think this is very science focused, but ultimately we've got to communicate really effectively, and that's what this is attempting to do with community feedback. So I mean, definitely provide feedback once you see this version 2 of the fast track proposal. If there are science holes that you think are identified, it's a good thing to feedback on, just to make sure we're not missing something.
Okay, thanks.
I think.
Yeah, just to follow up, I mean, very impressive number of activities that are going on, and the request for community input. I was really wondering how you guys are communicating with the community, because many of the things that you've been talking about, I wasn't aware of at all. In the end, of course, you mentioned that the CMIP mailing list, which is a great, probably one of the main conduits through which you guys communicate those requests to the community. But I was wondering if you could talk a little bit about that, more about that, how
Yeah,
people
sure.
could actually be engaged.
Yeah, sure. So prior to having the International Project Office, it was something that we didn't really have a centralized hub that was doing a lot of the administration. At PCMDI, we were doing a lot of the work to try and facilitate modelling groups and build coherent experiment design, whatever. But we've got science that we're trying to do in addition to all of this other stuff, and so having that administrative hub has been really quite helpful. They've then been able to stand up these surveys, which we've been designing the surveys, but the IPO has been implementing them. There are social media channels. There's the WCRP-CMIP.org website, which a lot of this information is collated around. There are mailing lists, etc. I mean, we're trying to engage in ways that we think is going to engage people. And we did have a town hall, for example, at the AGU meeting, but we didn't get as many people there as I was hoping, actually. And so trying to figure out how we connect to different communities, making sure that program managers have information and engagement opportunity, that they can then distribute through different agencies or, different communities would really be key. So, I mean, I'd really recommend folks sign up to the mailing list to make sure that, when information comes down and timelines are set, what those opportunities are. But, if there's another way that we're not doing something and you think it would be useful, just provide that feedback to me and we'll try and figure out how we can make that a reality. Because, I mean, community consultation is a primary aim of the IPO.
Mm-hmm. Great, thanks. I have some more questions, but I'll hand it over to Hailong first.
Sure. Thank you. Thank you, Paul, for a very informative presentation. A question about the complexity or the forcings for CMIP7. I heard that CMIP7 simulations will recommend more on the emission-driven rather than forcing-driven. Like CMIP6 models, lots of models prescribed ozone and gases and like aerosol precursor gases. So is there any recommendation for, given that more models are now having comprehensive representation of gas chemistry and coupling with aerosols, is there any recommendation that for any model, if they have the capability, will use more interactive chemistry and aerosols?
Yeah, so there's a real push, and like it's a significant push actually, and we've heard this very, very clearly. Emissions-driven rather than concentration-driven simulations are something that there's a lot of appetite for. There is a challenge to that, however.
Oops, looks like, yeah. Sorry, you were frozen in between, so you might want to restart and replay.
Okay, no worries. So what I was trying to say is there's been a huge appetite for emissions-driven simulations. Many, not all, but many of the models that are contributing to CMIP6 are actually Earth system models. So they do have ocean biogeochemistry, full carbon cycle, for example. The carbon cycle is a big uncertainty that we need to get a much better handle on as we go towards mitigation scenarios, for example, because if it doesn't respond, in a very linear way, then we need to know about that, because that's going to change the trajectory of, what we need to do in order to solve the CO2 emissions problem. It's a balancing act, though. This is the challenge. In a situation where you have a free ESM, an Earth system model running on emissions, you may get into a situation where the model historical 2023 has a very different atmospheric concentration to what we have now, just because the model can do what it wants to do. And so for argument's sake, we could have a model that has 350 ppm rather than the 420 or whatever we are at the moment. How do you then compare those models? And it comes down to your science question. It's really important, I think, that we do factor in that carbon cycle uncertainty, and we learn by using ESMs, because they are the most cutting edge, tool that we have at the moment. But if you're trying to attribute, forcing, for example, so greenhouse gases, what's the impact of greenhouse gases, which is what the detection and attribution MIP has been focused on. If you have something you're initializing with a 350 ppm versus something that you're initializing, you know, your simulation from a 450 ppm, you're probably going to get pretty different answers. So it's one of the things that we really need to try and balance up when we're coming up with the experimental design. There's a number of folks that are advocating for emissions only. But we've got, you know, 130 plus models that were contributed to CMIP6, and many of those do not run in an ESM and an emissions driven mode. And so we've got to try and figure out those things as well. When it comes to forcings, it gets confusing as well, because if you have emissions, it's a point source at the surface of the Earth, presumably for things like, you know, volcanic forcing, for example. But if you don't indicate the lofting of the sulfate aerosols in the atmosphere where it gets to, you could have a very different response in a model where it hits the troposphere and goes no further, versus, you know, gets up into the stratosphere in the high altitude atmosphere. So trying to make sure that we're actually building these experiments and being cognizant of the decisions we're making and how that's going to challenge us to try and interpret the output is something that we need to do. So there's a lot of consultation to try and figure out how we can try and serve, you know, broad science questions by limiting the requests of the different modeling groups.
Great. All right. Thank you very much.
So I see Hazel's hand up. She gets priority over Wilbert and Wiesler for the time being, and then we'll come back.
Cool.
Sounds good. Thanks, Renew. I just, recognizing the time, want to do a quick check-in. We're really close to the top of the hour. So if you do need to leave, I just want to remind you again, thank you for joining us today, and remind you that you'll be able to find the recording on the YouTube channel and on the IRBIT Collaborations website, and I can repost that link as well. Paul, if you have a few more minutes, it looks like there are more questions, and I'm happy to keep the room open for a little longer.
Yeah, that's
so
fine.
folks,
Yeah.
Okay. If folks would like to stay on, feel free to do that. We have another 10 minutes or so before I have to jump off. So yeah, feel free to raise your hand if you have questions, and I will pass it back to you, Renew. Thanks.
Thanks. I might have to jump off too, but Wilbert, can you take over at this point? Maybe Wilbert, since you've asked a question, we'll hand it over to Wiesler, and then you can take it over. Thanks. Wiesler.
Okay.
Okay, thanks. So, Paul, very appreciate the review of the device, how monster it is. But my question is very simple and focused. We're talking about here polar, Arctic, and stuff. Many people will agree with me that in order to provide the capability for model representation of the Arctic climate and polar climates, you need to increase into high resolution, both spatial and temporal. My understanding between CMIP3 and CMIP6, there isn't much of the increase in the resolution. You had on one of your slides, you had something about model resolution. I was trying to understand that. I missed that. Maybe that's not important, but I was wondering, what's your perspective, and what are the ways? You mentioned exascale, for example. Are people looking into increasing the model resolution for CMIP7 or CMIP8 or something? Is this something of a concern, or is it just a matter of a very small community of polar researchers that are focused and emphasizing this need, but it's not necessarily the big deal for global modelers centers?
Yeah, I mean, so like, within A37, for example, the regionally refined grid, there are these kind of approaches that different groups are taking. Obviously, it depends on your science priorities. So, for example, I can't imagine that the Australian community would be very interested in turning up the resolution in the Arctic. They may be interested in turning up the resolution in the southern hemisphere. So it kind of depends on what your science priorities are. Now, having said all that, there is the High-Res MIP2 project, which is focused on increasing the resolution and pushing models to higher resolution. I'm not familiar with the plans at the moment because they're currently trying to come up with, experimental design, etc. I don't know what different modeling groups are trying to do, whether they're thinking about, telescoping resolution. So you'd have very high resolution in certain parts of the globe, and, similar to what the regionally refined E37 configuration is doing. There's also the OMIP community as well. I mean, the way that I think about this is that I think about the DEC simulations, you know, that the core component there, the historical simulations, as being something that is a really good way to try and benchmark the global performance of models. If you want to do that, then you're going to have to make some judgment call about, you know, what regions you're going to, you know, whether you're actually going to go for, you know, a pretty consistent global grid, or whether you want to do regionally refined, etc. That comes down very much to the modelling group and what their priorities are. There has been a real call to push resolution, to try and resolve many more processes. There's a real push at the moment, you know, to try and increase the resolution of the atmospheric models, for example, but that's going to come at a cost of complexity or the total amount of time that you're going to run the simulation for. You know, so you might be able to run a model at 1 kilometre resolution, but you've got 30 years of simulation, and you've got to, you know, turn off oceanbed biogeochemistry and a whole bunch of other stuff that is actually really important. So it ultimately just comes down to a judgment call about resources. Having said all that, one of the things that I think would be important for this community in the situation, I think we've talked about this before, Westlaw, where there's data that was not requested and not made available from simulations, that would be a key opportunity right now to make sure that you say, look, you know, if a model captures XYZ variable, can you please make sure that that is saved alongside, you know, sea ice concentration? And I think like doing that right now is a great opportunity to make sure that we make the most of what we're going to get when CMIP7 lands. And we don't miss science opportunities by, you know, having to go and bug different modelling groups to, you know, to dig out an output that should then just be readily available. I think that to me is a real opportunity that we should make the most of. And if we then have that output, we can then make pretty tight justifications as to why turning up the resolution, you know, in the Arctic, for argument's sake, is really important. There are a number of Arctic and Antarctic focused MIPS, and I think like raising those kind of questions through those communities would probably be a good way of doing it. IMIP obviously is another community that's pretty receptive, I think, to the Ocean Model Intercomparison Project.
Yep.
Does that answer your question somewhat?
Well, it does. I didn't expect to have an answer that there's no one single answer. So
yeah,
yes,
it's true.
Thank you.
Yeah, I think, I mean, this is the opportunity that we have right now is engaging. And so the thing is, if you've got good science ideas, I think we need to make sure that the best science ideas are what's, you know, driving the projects really. And then you've got a judgment call as to, you know, where you're going to put the resources. You know, the IPCC assessment report is something that is probably going to be driving, you know, some of the priority contributions, but it doesn't need to, you know, dictate what the science focus of different groups, for example, is. And so if we've got a really good question, I think that should, you know, bubble right up in the importance in the community MIPS for sure.
Thanks.
And I think, Will, you've got your hand up as well. I think you're muted too.
Sorry, yes. If anybody else has some questions for Paul, please raise your hand. We really want this to be an interactive discussion. I do have a question about the additional MIPS. So I think that in CMIP6 there were maybe about 30 or so tag-on MIPS. So my first question is, what is the kind of the procedure for this? For initiating new MIPS or for other MIPS to continue? Are they all going to be endorsed by CMIP, or how does the procedure work? And I guess the second part of the question is there anything you can tell us about these polar-focused MIPS like ISMIP, CISMIP, Polar Cortex? And this might also be a question for people on the call that might be involved in any of those activities.
Yeah, I'm fairly sure that the QR code that's now up on the screen is going to point you at a web page which the IPO is managing, which is trying to capture information about activities, MIPS that are going on. Those MIPS don't need to be aligned with CMIP. Like I mean, the MIPS that are up on the page at the moment, all of these things have happened within a community. Very few of them actually are even bothering to leverage or, you know, want to leverage the CMIP infrastructure, for example. So Sophia MIP, for example, is something that fits. It's the Southern Ocean focused MIP. So FAIR-MIP is pretty interested in engaging the same modelling groups, for example, that contributed to CMIP6, and then wrapping their data sets up in that summarized format, which makes it easy then for people to to pick them up, use them. A number of things like Glacier MIP, for example, those are completely independent activities. I know about them because I was reading about them when I was trying to put together some of the AR6 information. And I mean, there's a lot of things that are going on that are running very neatly in parallel to, to this coupled model intercomparison project itself. And quite a number of them are using input from, different phases of CMIP. So I know Glacier MIP, for example, was using some of the forcing fields from scenarios to try and get a handle on, what the glacier response will be to back in CMIP5 and RCP 8.5 or whatever. So I think there's a lot of interaction between these things, and there's a lot to be learning, I think, as we go forward. So I think that utility to a broader community, it would not surprise me if many of these different activities that are listed on the page here are heavily dependent upon CMIP5, CMIP6 output, and probably also planning to be using CMIP7 when that becomes available too. So just trying to make sure that we have, for example, same comment that I made to Weissler, making sure that we have the output required. If you've got a sea ice quantity, for argument's sake, that the models are actually simulating, but we're not requesting it, we need to make sure that we put our hand up and say that we need, thickness in addition to concentration or whatever additional information we need. So making sure that that's not forgotten, when we're requesting the data.
Right. So, for instance, the NA host map, that's the one that I'm a little bit familiar with. Has it been endorsed? Is there some language for that, or is it just totally independent of CMIP? Is there any connection, really?
And Paul, could you just briefly go over what endorsement in CMIP6?
Yeah. So so it's a good question, actually. So the intention that we have at the moment is that we want to really try and leverage the infrastructure investments that we've had at the moment. Now, having said all that, well, I'll continue down that path. So the CMOR software was developed at Livermore for CMIP3, which enables a lot of modeling groups to write their data sets into a CMORized format, which is a single variable per file, etc. That software has evolved over the phases of CMIP, so that in CMIP6 we had CMOR3. That uses, it basically enforces the CF conventions and then adds a number of attributes to the global metadata in the netcdf file, global attributes in the netcdf file that captures information about the model that is very, very useful when you want to try and interpret the data that sits in the file. So that infrastructure stack is available for anyone to use in a situation that you wanted to CMORize your data sets. Now, having said all that, if you are not a part of the CMIP activity, there's not infinite resources to aid these different processes. So what we're trying to do at the moment on the infrastructure side is really try and make that the infrastructure much more logical, which means that it should be reusable by groups that want to use it without having to, register, engage, and do many things. At the moment, that's a work in progress, but the CMOR stack has been used across OBS for MIPS, used in input for MIPS, and a number of other projects to try and bring, these observational or the forcing data sets more in line with the model output itself. And what that's really aided, particularly in the forcings, the input for MIPS project, is it makes it easier for the modeling groups to use these data sets because they don't have some, unusual format they've got to figure out how to interpret it as well. So there's a lot of advantages to it. So on the question of endorsement, in CMIP6, the CMIP panel chose to endorse MIPS. And so of the 20-something MIPS that contributed to CMIP6, so FAF MIP, SI MIP, IMIP, PA MIP, etc., they were endorsed. And the endorsement process in CMIP6 was you come along with a scientific idea that fits neatly into the WCRP remit for climate research. It aligns pretty neatly with the previous phases of what CMIP3 had done at the time. Well, in CMIP5 had done at the time, I suppose. And then it's going to serve the needs of the community that WCRP represents, and also the infrastructure providers, the modelling groups, etc., are aligned with that. So the way that it worked was back in CMIP6, if you had 8 modelling groups that said, "Yep, no problem, we will contribute to whatever MIP it was," then that was enough for that to kind of, get endorsed and become part of the CMIP6 stack. With CMIP7, because things have broadened so much now, the endorsement process is not going to be run the same way. So there will be prioritized experiments within this fast track that the CMIP panel is trying to coordinate across different MIPs that have contributed to CMIP6, for example. But the community MIPs can occur on a time frame that they want. What resources they have access to from the infrastructure point of view, they will have access to Seymour. They'll have access to the input data set, the input deck that Seymour uses. But depending upon their involvement in, say, CMIP7, the amount of support that they're going to get to use that is going to be, it's going to have to be prioritized to fast track, and then, the other activities that are actually formally aligning with the CMIP7 phase. But for example, within DOE, we have the ESGF project, which has dedicated storage. We have the Seymour software that facilitates the output to generating the output. So it is something that should be easier to do than it is in the past. It's still an investment, but ultimately it makes it a lot easier then for the ESGF project itself to curate these data sets in a situation where you wanted to run it your own MIP, for argument's sake, and you have, say, 10 modeling groups that are scattered around the globe that want to contribute to that. If that MIP decides that they are going to enforce the Seymorization step, it then means it's going to be far, far easier to stand up a federated project where, US groups could publish to US ESGF nodes, European groups could publish to ESGF nodes over in Europe, and then that federated project would be made available to the community. So you may be downloading data sets from, from Germany or France or wherever it is, but we could also then use the replication software that runs at the back end of ESGF to make copies of those things in a situation where you had the support of the infrastructure providers. So it's very much trying to reuse to enable science to be done. So hopefully that answers your question in a very, very long answer. Sorry.
Very, very nice. Thanks, Paul. Are there any more questions for Paul about this?
There are no questions in the chat either, I don't think. Oh, good. Well, I'll make sure that I provide a finalised version of these slides through to Hazel as well, so that they should be available, through the portal there. And obviously, all of this information will be, up on YouTube as well, which will be great. Yeah, and if anyone has any questions, to get back to the last slide, if anyone did have any questions or has some ideas or whatever else, feel free to hit me up on the email there. And also make sure that you subscribe to those mailing lists, so when new opportunities come around, you know about them first thing.
Excellent. Hey, thanks so much, Paul. Really appreciate your presentation. It was extremely useful for this community.
Yeah, no problem.
I hand it over back to Hazel, and she can close things down here.
Nothing else to add. Yeah, thanks so much, Paul. Thanks everyone for joining, and keep an eye out for that recording, and feel free to pass it along to your colleagues who missed today. Right. Thanks so much. Happy holidays if you do holidays, and otherwise I still hope you have a restful, relaxing couple of weeks. We'll see you in January.
Thank you.
Thanks. Happy holidays, everyone.